Today we will discuss about the different system of nomenclature of geometrical isomers. Geometrical isomerism, you know that it is a form of stereoisomerism describing the orientation of functional groups within a molecule. And in general, such isomers contain double bonds which cannot rotate, but they can also arise from ring structures wherein the rotation of bonds is greatly restricted. Now, type of nomenclature. There are three types of nomenclature systems for geometrical isomers. One is very common, that is cis-trans nomenclature system. Second, EZ system of nomenclature. And the third one is syn-anti system of nomenclature. So there are three types of nomenclature system in case of geometrical isomerism. Geometrical isomers are named according to these three systems: cis-trans, EZ and syn-anti. Now, cis-trans nomenclature, the most common system of nomenclature, which is presently obsolete. IUPAC is not considering this system of nomenclature. Anyway, as it is very common, and it's very popular, we have to discuss about this method. Compound of this type, that means when in a carbon-carbon double bond, with both the carbon atoms, same two substituents are attached. That means each carbon contains two different substituents, but these two substituents is again attached with the another carbon of the doubly bonded attached carbon atom. This form of molecules can exist in the cis-trans form due to their frozen rotation about carbon-carbon double bond. And the isomers in which the identical groups are on the same side of the double bond are called cis isomers, and the isomers in which the groups are on the opposite side, they are called trans isomers. For example, 1,2-dichloroethane. If you see dichloroethane, 1,2-dichloroethane, when both the chlorine atom on both the doubly bonded carbon atom remain on the same side of the double bond, that isomer is called cis isomers. And when the chlorine groups or chlorine atoms on both the doubly bonded carbon atom remain on the opposite sides, these isomers are called trans isomers. Now, EZ system of nomenclature. It is observed that when all the four substituents in the two doubly bonded carbon atoms are different, if all the four substituents are different, then it is very tough to name these isomers following the cis-trans system of nomenclature. If you see the second one here, you see the second structure where fluorine-chlorine is attached with the first carbon and iodine and bromine is attached with the second carbon atom. Here, if you have been asked to name this isomer according to cis-trans system of nomenclature, can you do? It is not possible, because you can't see that in which side the same substituents are present on the double bond. So this type of compounds, these types of molecules where all the four substituents are different, then this cis-trans system is not applicable. So a new method of nomenclature is required, and a new system of nomenclature, that is EZ system, had been introduced in 1968 for naming this type of compounds. Kahn, Ingold and Prelog introduced this nomenclature system, and it has been accepted by the IUPAC, and actually presently cis-trans system is obsolete. This EZ system or EZ method of nomenclature is applicable for all types of geometrical isomers. It follows the sequence rule or the priority rule, which has been developed for naming optical isomers by RS system, and that method has also been developed by Kahn, Ingold and Prelog, which has been later introduced for naming geometrical isomers. So the sequence rule or the priority rule is used to numbering the priority of the substituents or considering the priority of the substituents at each of the doubly bonded carbon. Each of the doubly bonded carbon has two substituents, and each of them has been numbered with the priority number. One with higher priority is given 1, and the less prior atom or group is given 2. So it is clear, you have to number the substituent according to its priority. Which has higher priority, it has been assigned number 1, and which substituent has the lower priority has been assigned with number 2. If the higher priority group or atom on both the doubly bonded carbon are on the same side, then that isomer is called Z. And if they remains on the opposite side, that isomer is called E. Here Z comes from a German word zusammen, means together, and E means entgegen, means opposite. This priority, it depends on the atomic number, same as your RS system in case of optical isomers. Priority depends on the atomic number of the substituent. More the atomic number of the substituent, higher is its priority. But when these two atoms in a carbon are isotope, say one is hydrogen, another is deuterium, or any one, say carbon 12, carbon 14, then in case of isotopes, if both the substituent on a particular carbon are isotope to each other, priority depends on the mass number of the isotope. The substituent which has more mass number, that means it has higher priority. In case more than one atom is there in a substituent, the atom which is directly attached with the carbon atom is considered for priority determination. And if both the directly attached atom with the same carbon is same, then the next atom which is attached with the first directly attached atom, that atom is considered. If the second atom on both the substituent of the same carbon atom is found same, then the next atom is considered. If the next is also same, then we will go to the next. In that way, finally we will determine the priority of each substituent. That means after considering all the attached atoms, it has been determined that whose atomic number is more. The more atomic number means its priority is more. Now in case of double bond in the substituent group, if in the substituent group there is one double bond or triple bond, it is considered that that particular atom with which the double bond is there, it is attached double with that atom, or if there is triple bond, that means it is attached with 3 times with this atom. Now you see the structures. The first one, C double bond C. With this first C, there is one aldehyde CHO, C double bond OH, and here C double bond OH. So the atomic number of this COH is obviously more than this CHO, because here is one double bond, then H, here is one double bond, then OH. So C double bond O is common in both the case, but here it is only H and here it is OH. So as the attached O, its atomic number is more. So as a whole, the atomic number of COH is more, so priority of COH more in comparison to CHO. So 1 is given with this COH and 2 is given, that is less prior, with this CHO group. Now in the second carbon, here one is CH double bond CH2, and another is CH2, CH2, CH3. Now double bond CH2 means with this C there is a double bond, which I have already said you. The double bond means this carbon is attached with this carbon doubly, twice. That means this C is attached one C above, one C here and another H. But here this C is attached with 2 hydrogen and 1 carbon. This C is attached with 2 carbon and 1 hydrogen. So its surrounding, if you see, there is 2 carbon, 1 hydrogen. It has 2 hydrogen, 1 carbon. Atomic number of hydrogen is much less than the carbon. So as a whole, total atomic number of this substituent is much more than this group. So it is more prior. Its number is 1, it's 2. So here you see, if you see the double bond, the one prior number, that's higher priority group, it remains on the opposite sides. So it will be N-gagen or E isomer. Here also you see there is one CH3H, and with this carbon one hydrogen and one deuterium, which is isotope. Deuterium, mass number of deuterium is more, so it is more prior, so it's 1, and this hydrogen is 2. Here methyl, its priority is more than in comparison with hydrogen, so it is 1. So 1 in this carbon is on the upper side and here in the lower side, so they are in the opposite side, so the isomer will be E isomer. So it is clear now, EZ system. Next is syn-anti system of nomenclature. This system of nomenclature is not applicable to all the geometrical isomers like EZ. EZ is the only system which is applicable to all the geometrical isomers. Cis and trans is cis-trans system is only applicable when each carbon has 2 different substituents and another carbon has these 2 substituents. When all the 4 substituents are different, cis-trans is not applicable. Syn and anti system. Syn-anti system is applicable only for nitrogen containing molecules like C double bond N, N double bond N, that is oximes, azo compounds. Here syn-anti system is applicable. Lone pair on the nitrogen is considered as pseudo atom. Nitrogen has one lone pair, it is considered as pseudo atom and another substituent will be there. And in this system, another thing which we have considered is that hydrogen and hydroxyl group, when attached with carbon or nitrogen, this H and OH are considered as same group. So whenever they are in the same side, it is syn, and when they are in the opposite side, same group on the same side means syn, that is like cis or Z, and opposite sides, if the same groups present, then it is called anti-isomers. Now you see some structures. In the first one, C double bond N. Here in the C there is one CH3 and H. In the N there is lone pair and CH3. CH3 both in C and N, CH3 in the same side, so it will be syn isomer. N compound, here N, with the N there is CH3, in this CH3, both the CH3 in the same side, so this compound will be syn isomer. The third one, CH3 on the opposite sides, so it is anti-isomer. Fourth, in the fourth compound you see H and OH, they are on the same side, and which I have told you that in case of syn-anti system, H and OH are considered as same group. So here the same group in the same side, so it is syn isomer. And the fifth one, the hydrogens are on the opposite sides, lone pairs on the opposite sides, so it is anti-isomer. This is whole about the nomenclature of geometrical isomers. So thank you.